Hello everyone, thanks for logging into the webinar. We appreciate you taking the time out of your day to attend. If you are responsible for using, maintaining, or designing compressed air blow-offs, this will be a very useful presentation for you. Today we want to talk about some simple steps you can take to save cost on your compressed air system. In many cases, improving your compressed air system can seem a huge undertaking with air audits, system controls, or new compressors. We want to focus on the individual steps you can take at every usage station to reduce your compressed air consumption while still maintaining your system's effectiveness. My name is Justin Nickel, and I joined EXAIR in 2014 as an application engineer. My previous background includes over 15 years of industrial fluid handling experience involving industrial pumps, mechanical seals, valves, and automation. So who is EXAIR? EXAIR is a manufacturer of compressed air products. We make air blow-offs, vortex tubes, cabinet coolers, industrial housekeeping products, and static eliminators, to name a few. All of our products utilize compressed air in some capacity. We were incorporated in 1983 and we're located in Cincinnati, Ohio. First, I want to answer why intelligent compressed air is important. Later, we will get to the how, where, and what. It is very simply money and safety. Compressed air is the most expensive utility in most plants. Inefficient blow-offs can cost thousands of dollars per year in wasted energy. Most estimates say that between 30 and 50% of all compressed air generated is wasted. We want to help you find the largest sources of this wasted compressed air. On the safety front, noise and dead end pressure will be the two topics regarding safe use of compressed air. So where is your money best spent? This compressed air presentation is different from most. Instead of talking about your overall system supply and demand, we are going to focus on the point of use. In many cases, folks preach to audit your compressed air supply to match the demand. They only want to ensure that the compressed air that you use is generated as efficiently as possible. In this presentation, we focus on trimming your demand in the first place, so that you aren't just cutting your efficiency, but reducing your overall usage. Once your usage is set, the compressed air audit can be even more effective to ensure that the air you need is efficiently produced. In other words, why would I want to install two high-efficiency 25 horsepower screw compressors when my plant only needs to use 20 horsepower worth of air? Finally, on top of the incalculable value of safety, there are very real fines associated with OSHA violations. I have seen fines from $6,000 to $10,000 for compressed air violations. Here's the first thing to look for when trimming your compressed air demand. Homemade blow-offs or inefficient nozzles. You will notice that many of these nozzles have cross-drilled holes. While this complies with OSHA's regulation for dead end pressure, the nozzles are incredibly noisy due to wind shear, which also may result in a safety violation. An open tube also consumes more compressed air compared to an engineered solution. On the right, we have a chart for compressed air usage. We will reference this later in our calculations for compressed air savings. Here we have compressed air users with the largest return to look for in your facility. Modified air guns starting from the left, a crushed air gun is a cry for help. The operator is mangling their tools to try and get more out of them, but this will not work. In most cases, this means that so much air is being used that you can't build up pressure inside the compressed air system to provide enough force. Next, manifold with open pipes. Each of these copper pipes could flow as much as 33 SCFM of compressed air. That whole setup would use 429 SCFM with 80 psi of inlet pressure. An air knife would be a perfect replacement here. Lastly, drilled pipe. Depending on the holes and their spacing, this can use a tremendous amount of air. Regardless of the air usage, this will still be a noisy installation though. We're going to get to an example shortly, but first a bit of background. In our literature, we use 25 cents per every 1,000 SCF used, and here's why. In order to calculate the cost of running an open pipe, first we need to calculate the cost of compressed air. This cost will vary greatly across the country as utility rates change. If you know that your electricity rate is significantly higher than 8 cents per kilowatt hour, you should follow along with the slides and do your own calculation. We start with a 20 horsepower compressor, which requires 15 kilowatt. At 8 cents per kilowatt hour, the 20 horsepower compressor costs $1.20 per hour to operate. If you have trouble calculating your usage, contact EXAIR after the webinar and we can run through the calculations with you. A 20 horsepower compressor running at maximum output will produce 80 standard cubic feet per minute or 4,800 standard cubic feet per hour. 4 SCFM per horsepower is a conservative rule of thumb. Some air compressors can make 5 or more SCFM per horsepower. Individual compressors and delivery rates may vary though. To produce 1,000 standard cubic feet per minute will take 0.2083 hours or 12.5 minutes. You will see 25 cents per every 1,000 SCF used in most reference materials on the cost of compressed air. We will use this in many of our case studies as it is a very reasonable number in the Midwest, but is conservative in Europe or other parts of the country. Let's start with one example. Calculate the compressed air savings and energy cost of a 1/4 inch open pipe versus a super air nozzle model 1100. There are a number of slides here, so please ask if you have any questions. On the left, we have an inefficient blow-off of a 1/4 inch open copper tube. This will use 33 standard cubic feet per minute at 80 psig of inlet pressure. On the right, we have an engineered solution, our 1/4 inch NPT super air nozzle model 1100. This will consume 14 standard cubic feet per minute at 80 psig as well. 1/4 inch open tube is such an easy band-aid fix, but as you will see in the next few slides, the cost of these homemade blow-offs quickly adds up. A 1/4 inch open copper tube uses more than twice as much air as the 1/4 inch 1100 super air nozzle. By installing the 1/4 inch open tube, you are basically creating a large leak in your compressed air system. I'll take a moment here. I know there's a lot of information, so if you want to take some notes. You'll see here that an 1100 super air nozzle saves over $2 for every 8-hour shift instead of the 1/4 inch open copper tube. I put it in green, but we'll say it again. The 1100 super air nozzle saves $570 per year in energy cost alone. This neglects the benefits in compressor maintenance, noise reduction, and OSHA compliance. Again, I'll take a moment here. There's a lot of information. You'll see at the bottom there that the return on investment by using the 1100 in place of the 1/4 inch open tube is going to be around 16 working days. Here's an example of a case study we recently published. A high-tech plastic producer operated 40 machines that used crimped 1/4 inch open copper pipes at 100 psig supply. These pipes consumed an average 40.4 SCFM of compressed air at 100 psig. They were able to cut off the crimped end of the pipe and install a 1/4-inch model 1100 Super Air nozzle, saving 23.4 standard cubic feet per minute per nozzle. Replacing 40 of these nozzles, they were quickly able to save over $29,200. Now let's take a look at the safety benefits of using an engineered solution. In addition to the cost to run these open pipe blow-offs or homemade nozzles, there are other considerations. OSHA put out this regulation in the 70s, and they did this because compressed air on an open cut or against skin can cause irritation, a minor health hazard. But if the air enters the bloodstream, it can cause an air embolism, which is a serious medical condition. If air is allowed to enter the bloodstream, it can disrupt the heart's normal function of circulating blood throughout the body. Depending on the severity, this can cause a range of threats, from abnormal heart rhythm, shock, heart, lung, or brain damage, possible stroke, cardiac arrest, or ultimately death. Our Super Air nozzles are designed to utilize multiple openings that are recessed behind a series of fins to prevent the nozzle from being dead-ended. With this design, the air always has a path to vent, so the nozzle produces air close to atmospheric pressure, well below OSHA's 30 psi-G dead-end pressure requirements. With our air knives, we only have one opening, but that opening is at least 3 inches in length, so it would be difficult to block. Even if you block the front of the opening, the cap overlaps the body, so that it will be a gap on the sides of the knife for the air to vent freely. All of EXAIR's products use some combination of these principles to bring you OSHA-compliant compressed air devices. In addition to dead-end pressure, noise is another important consideration in safety. These homemade nozzles or open pipes create a tremendous amount of wind shear, which creates a high-pitched compressed air noise that is annoying and can be painful. OSHA has outlined a maximum allowable noise exposure table to protect workers from constant noise. By using an engineered air nozzle, you will reduce the noise, and with the smooth flow the nozzle creates, it does not feature that piercing wind shear noise, which is especially painful and distracting. Noise in the workplace. Nearly 30 million Americans are exposed to dangerous workplace noise levels on a regular, if not daily basis. Noise-induced hearing loss is one of the most common occupational diseases and the second most self-reported occupational illness or injury. Since 2004, the Bureau of Labor Statistics has reported that nearly 125,000 workers have suffered significant permanent hearing loss. When applied to the national workforce, occupational hearing loss costs an estimated $242.4 million per year in disability alone. Industries with high number of exposed workers include agriculture, mining, construction, manufacturing and utilities, transportation, and the military. Loud noise can create physical and psychological stress. It can reduce productivity, interfere with communication and concentration, and contribute to workplace accidents and injuries by making it difficult to hear the warning signals. So what makes a product intelligent? Basically, it's engineering. Compressed air is typically a manufacturer facility's most expensive utility. Any pipe, manifold, or fitting can be modified to blow compressed air, but these homemade blow-offs will be very noisy, waste a tremendous amount of compressed air, and create an OSHA violation. In contrast, EXAIR's intelligent compressed air products are an engineered solution which are quiet, use a minimal amount of compressed air, and comply with the OSHA safety standards. EXAIR Super Air Nozzle utilizes an engineered design that emits compressed air for a primary airflow. This fast-moving jet of air creates a lower pressure around the air nozzle, which induces the flow of free or ambient air from the environment. This induced airflow is 25 times the amount of compressed air used by the nozzle. This means for a smaller amount of compressed air used, we create a larger force than a compressed air device alone. The benefits of intelligent compressed air products. The design of our products prevent dead ending, as there isn't a way to block the exhausting airflow, providing relief for the air to exit at pressure well below 30 psi. In addition, it also abates wind shear that makes straight, open-end blow-off so loud. By entraining a high volume of air from the surrounding environment across the profile of the nozzle, we are not only able to reduce the noise level, but also produce much larger volumes of high-velocity airflow, resulting in a more efficient operation by reducing compressed air consumption, ultimately lowering your energy costs. In fact, many utility providers have recognized the benefit of using such engineered solutions and now offer rebate programs to encourage users to lower their energy demand. We can help you with sourcing potential rebates for your state to maximize your savings associated with upgrades to engineered product solutions. So what are the next steps? By measuring your compressed air usage, you can locate the source of high usage areas and monitor the usage on each leg of the system. The easiest way to reduce compressed air usage and save on operating expense is to turn off the compressed air to a device when it isn't needed. You can use a device like our electronic flow control, or EFC. This helps minimize compressed air usage by incorporating a programmable timing controlled sensor to turn off the compressed air supply when there are no parts present. Another method would be to use some sort of valve, like a manual ball valve, solenoid, or a foot valve, for instance. Compressed air leaks can result in a waste of up to 30% of a facility's compressor output that we mentioned earlier. This not only wastes energy, but it can also cause the compressed air system to lose pressure, which reduces the end-use product's performance. A compressed air leak detection and repair program can save a facility this wasted air. Our ultrasonic leak detector is designed to locate the source of a leak up to 20 feet away. EXAIR's digital sound level meter is an easy-to-use instrument that measures and monitors the sound level pressure in a wide variety of industrial environments. The source of loud noises can be quickly identified so that corrective measures can be taken to keep sound levels at or below OSHA maximum allowable exposure limits. EXAIR offers a free service where you can send a sample of the product or products you use for your applications, and using our calibrated testing equipment, we can compare the performance of your existing product to an EXAIR engineered solution. During our confidential testing, we can determine air consumption, noise level and force, and publish a comprehensive report, including a cost savings analysis. This time, I just want to thank everyone for attending today's session. If you do have any questions, feel free to contact an application engineer at 1-800-903-9247. We can also be reached by email at techhelp@exair.com. That's techhelp@exair.com. Again, just thank you for attending today's session, and I hope you have a great day.